Righto, final session of the day, PBS vehicles. So this was a good lead-in from that conversation that we had in the last session about tyres and airbags. So Les, you can go first if you like, and then we'll do the Snowy case study. Is that okay? Happy to go first? Yep. Cool. So this is Les. He is the Chief Engineer at NHVR. So he's going to give us a bit of an overview of what PBS is all about. Do you want to share your screen or do you want me to run it?
I'm happy to share my screen if that's all right.
Yep, perfect.
Good morning everyone. I've got a few slides. I'll try to go through them really quickly. I'm really sorry that I cannot be there because this forum is absolutely fantastic. It's one of my favorite events, and unfortunately I had a knee operation, a knee replacement a couple of months ago, and I'm still recovering. So forgive me that I cannot be there in person, but my soul is there with you this morning. Just quickly about PBS, it's a very quick rundown because we're going to have a panel session so you can ask questions. But in terms of the background, I think the last few years with COVID-19 emphasized for people outside of the industry the importance of road freight and the importance of supply chains, and I guess it created a different environment for all the businesses involved with road freight transport. I guess the other changes in terms of customers, the habits of what we are doing, and online purchases and just-in-time deliveries and so on. So in terms of the proportion of transport which is transported on road is increasing. And on the top of that, we've got driver shortages, all those things which are affecting your industry. So the efficiency of the transport area is critical for the economy and for the country in general. In terms of PBS, I can report you that despite of COVID, you can see a significant increase in terms of PBS combination numbers. So you can see that in 2021 we approved more than 2,100 combinations, PBS combinations. And if I look at the figures, these figures are at the end of May. We're gonna probably hit around 2,000 combinations this year, so it's in line. What it means that we've got more than 14,000 PBS combinations approved in the country. So it's not a niche market anymore, and transport operators are starting to utilize these combinations more. If we look at the fleet, it's still truck and docks, the most popular combination in terms of PBS combination types. But what's important that if you look at A-doubles, they are now the second most popular group, and there has been a significant increase in terms of the A-double numbers, both around the 26-meter length and the 30-meter length. And we just issued a notice last week, and I would like to congratulate Victoria and New South Wales being extremely proactive, looking at these combinations, and now we have basically a 30-meter PBS level 2B access between Sydney and Melbourne, which is a huge achievement for PBS in general. In terms of some more stats, again, I emphasize that PBS is not just about the large, big combinations. If you look at the graph on the left-hand side, you can see that level 1, level 2, and level 1 and 2 combinations would still represent around 95% of the PBS fleet if we look at access level. And if we're looking at length, you can see that around again 95% of the combinations would be under 30 meters, so those are the most popular. Having said that, what's also interesting that with innovative designs we can see a huge change for some of the freight specific areas. So in terms of those PBS examples, it's not just grain and truck and docks, it's all the different axle configurations, container vehicles. We've got innovative logging vehicles now as well, for carrying big tires. So PBS is penetrating into all the different areas within the industry. Here is another one, a beautiful B-double, and what's interesting that you can see the application of innovative axle configurations. So, for instance, in this B-double, it's got split axle groups. If you can see those axle groups. Those are not normal tri-axle groups. Those are split groups on those trailers. And I guess in terms of all those productivity benefits, I want to emphasize, because safety is critical for the discussions of this forum. Every year that we completed a study last year about the safety performance of PBS vehicles, and we compared that to the prescriptive fleet. And if you look at the conventional versus PBS crash rates, if we look at rigid trucks, there is roughly a 50% reduction in crash rates per 100 million kilometers. But if we're looking at Arctics, the difference is even much bigger. And then if we look at predictions using those sort of crash rates, in a conservative prediction, we would save around 140 lives by 2023, which is always significant. And then on the other chart, you can see that again those 69% reduction in terms of crash rates. But again, productivity is the name of the game for most of the transport operators. And this chart, sorry about the lots of numbers there, but I guess the key number is if we want to describe the productivity benefits of PBS combinations, we've done these calculations that since the introduction of PBS, the PBS fleets saved around 3.3 billion, again, billion truck kilometers traveled. And that's what it means. It means less exposure, it means less heavy vehicles on the road, it means less environmental effects or less impacts on the networks, which is critical for the road managers. If we look at the number last year, it was 593 million kilometers. Obviously, with the increased number of PBS combinations, that number is going up. And I guess my last two slides here, PBS access, obviously that's a critical element for road managers and operators. And I guess since last time when we had the forum, there have been some changes. One is that we've got a new category in the law, the specified PBS vehicles. Those are level 1 vehicles which are not longer than 20 meters and they have a VA and they are loaded to GCM limits. They can have automatic access to the general access networks. And I guess the notices, what we've been working with the road managers, there are a large number of PBS notices now available, which would give some certainty to PBS operators in terms of making it sure that they can have access. And just quickly about the future, we are working on a few very important PBS related projects. First is the marketplace review. which is dealing with the review of the existing standards. PBS was introduced around 15 years ago, so it's time to review the standards to see if they are still relevant for the current fleet. We are planning to do a baseline review that's just making it sure that that sort of performance gap between the prescriptive fleet and the future PBS fleet is still there. The generic tire, and I'm pretty sure there will be questions about that, so I can talk about that later. And also PBS 2.0, reviewing the whole scheme strategically and see how we can improve it more, making it more user-friendly and making it more accessible for the industry in general. So I think, sorry, it probably was more than 7 minutes, so that's the end of my presentation, and I'm looking forward to your questions in the panel session. Thank you very much.
Thanks, Lance. So this transporter not dialing back into this session. So the last speaker is a local case study. So I'll introduce you to Roy Trimmer from Midlands Industries over in Parkes, who's going to run you through the Snowy 2.0 trailers. And I'll go and get your slides. And there's your thingy.
Thanks, Mel. Thanks for coming, everyone. I'm Roy from Midland Trailers in Parkes. We're obviously away from Mel to get the slides going, but we've got the 30 metre A-double sitting down the bottom there that we'll have a look at a bit later on. But what we're here to talk about today is the Snowy 2.0 project, which is an iconic PBS project. It's now up and running successfully. So who is Midland? We're a family-owned business from Parkes, founded by Ben and Martin Larson, two brothers from Cowra. They been handy on the tools, started making four-drive trailers, and then they got an order for a tag trailer from Blaney Shire Council. The rest is history. We're committed to manufacturing the highest quality plant and general freight trailers. Our equipment is designed and engineered, manufactured to be a benchmark in a globally competitive market. Recently, obviously, due to the Snowy project and some other larger projects we've had on, we've expanded quite a bit, had some extensional growth. We've moved to a new facility in Parkes and opened up a branch in Victoria, and recently just the admin office here in Victoria as well. So the Snowy 2.0 project was quite a task to overcome. We got approached by the client in early 2019. There was a requirement to carry, we'll push on to that later, but what is the Snowy 2.0? It's a extension of the iconic Snowy hydro scheme. It's a 27 kilometre tunnel that is Australia's largest committed renewable energy project. The tunnel is 27 kilometres long. Each ring is 12 metres external diameter and 9 metres internal, and there's 9 segments to make up a full ring. So each ring is 2 metres wide and they weigh 7 tonne each. And then the requirement was to transport 9 segments per truck to site to keep up with the flow for the tunnel boring machine. So they feed it into the tunnel boring machine in order. So there's 63 tonne per truck, and there's 135,500 segments to be moved from the Cooma concrete factory down into 3 sites where the tunnel borers operate. So we started off with a quad axle semi-trailer. Obviously payload alone would have been too much for it, and just physical pavement wear and access into the Snowy Mountains wouldn't have worked at all. So we looked at reducing the payload to 6 segments per truck. Obviously that would then increase the amount of trips required to site to 25,500 truck movements. So we come up with our PBS consultant, we put our heads together and come up with this Mini B triple. It's 26.5 metres long. You get 9 segments per truck, and it reduced the number of truck movements through the middle of Cooma to 15,000. So they're successfully in operation at the moment. We also had to design and develop and certify a load restraint system that removed human error. So this system works, is certified to operate at minus 20 degrees. It's hydraulically restrained automatically with a tensioning sensor. So as they drive along the road, if the straps, the load shifts or whatever, it retensions. A bit like the air operated ratchets that the truck, the logging industry uses, but obviously produces 8.8 tonne of pre-tension to restrain the load. All working very well. It's a little video here to watch.
Welcome to Lobbs Hole, the heart of construction for Snowy 2.0, a pumped hydro expansion of the mighty Snowy scheme and Australia's largest committed renewable energy project. Future Generation is the joint venture partnership between WeBuild, Lane and Clough, building Snowy 2.0 on behalf of Snowy Hydro. This month, we'll bring you all the progress from Talbingo Adit and Intake and showcase the purpose-built Snowy 2.0 segment trucks and their safety features. Let's take a look at what's been happening. We have a fleet of custom-built trucks that carry concrete segments to line our tunnels and are manufactured at our Cooma factory. Each vehicle is equipped with innovations and safety features designed to suit alpine conditions and ensure every load is delivered safely. Using these vehicles reduces the number of truck movements by about 2/3. A special lashing system has been developed to tie down the 3 stacks of concrete segments on the trailers. Timber dunnage with rubber on the top and bottom is used between each segment to protect them and prevent movement during transportation. The 9 segments on each truck plus packing support weigh 63 tonnes, so it is vital these segments are properly restrained. Once straps are attached, the load restraint system is engaged. A green light on the trailer and in the cab of the truck indicates that the segments are secure. There is also an audible warning for the driver when the system is operating and tensioning the load. If the load shifts during transport, the driver is alerted immediately by a red light in the truck cab, allowing the driver to pull over in a safe location and retension the load. The segment truck fleet is under continuous video surveillance. Each prime mover is fitted with 4 cameras, providing the driver with excellent visibility. The cameras also record journeys, act as a driver development tool, and can be used to investigate incidents. External safety lights indicate the load on every trailer has been properly secured and also help illuminate the long trailers in dark and foggy conditions. If you come across one of our segment trucks driving in the mountains, please be patient. Our drivers will pull over into the designated slow vehicle turnout bays, giving you an opportunity to safely overtake.
It's good, thanks Mel. So you can see them in operation there, and obviously PBS has come a long way, as we had the stats from Les before. There's some good stats supporting PBS and its benefits and improvements for the productivity of freight in our country. Any questions? I look forward to hearing from them.
Good work, Ryan. Awesome. You can keep that for your questions. Yep. Les, we might go to you first because we had some questions in the last session about airbags.
Airbags. What about airbags?
Who was it that asked that question about airbags? Wayne's going to tell you all about it.
I guess I'm...
Well, do you want to get an answer from the chief engineer?
No, it's Wayne Dunford, Les, from Parks. I just raised it earlier. The industry talks a lot about, and even discussions over a cup of tea here, that airbags seem to be doing a lot of damage to our pavement. And we're just wondering whether there's something that needs to be looked into a little bit more and how they could be better equalised or whatever might be the answer, because, you know, the industry talks about, the buckets of things, so to speak, to put it mildly, for a lot of reasons. Have you seen anything like that emerging, that they could be causing damage to pavement?
Okay, this question, it's a very valid question and it comes up all the time. Obviously, because we've got legislative differences in terms of what you can carry with a vehicle which is fitted with air or road-friendly suspension versus steel suspension. So I don't want to go back to history because it's been, we started to look at this in details back in the middle of the 90s. We had, and then we had mass limits review around 2000. So there have been lots of research and investigation about the performance of road-friendly or air suspension versus steel suspension. It's been established that road-friendly suspension in general is delivering significant benefits in reducing the dynamic loads on the pavements, and this was the rationale behind allowing them to carry more mass. But it's true that if suspensions are not maintained properly, and that's which is a risk, that if they are not maintained properly, then you could have a situation when airbags, when a vehicle which is fitted with road-friendly suspension is not performing that well. So currently we will be reviewing VSB 11. I hope in the next financial year, which is the set of rules which would cover the performance of air suspensions or road-friendly suspensions. We've done lots of testing in terms of trying to establish some sort of in-service standards because currently we don't have in-service standards available for suspensions. Like if you compare the suspension system with brakes or even with tires, there is an in-service sort of consideration, understanding how much the performance of that particular component will change in service. So we are doing additional research and trying to understand all those aspects of the operation of air suspension which haven't been researched in the past. So we are looking at it. I'm not sure if I'm fully responding to your question, but I just I want to emphasize that yes, we are doing work in that area.
Thanks, Liz.
Questions from the floor? Gavin.
Yeah, Gavin Tom from Parks. Just interested in what you were talking about with the tyres. Just what that was about, please.
So, yeah, from the, I would probably separate our work in terms of the tires. So, obviously, currently, the management of tires on PBS vehicles is probably the most critical issue. I'm not talking about access, but in terms of the vehicles, considering the supply chain issues and the availability of tires for the industry, and also practical considerations like changes in terms of tire models, makes and models, and the cost of tires. The situation is that currently for every PBS combination, individually we have an approved tire list which specifies which are the tires which can be fitted to a vehicle. And that's not really practical, and it causes lots of operational problems for the industry. So we are trying to introduce a new system, and we are very close to it, which means that we are getting rid of the individual tire specifications for individual vehicles. We will be assessing the vehicles with the generic tire data sets, and that means that operators will be able to fit any brand of tires, provided that the size, load rating, and speed rating of the tire is compliant with the PBS specification. So that's what we are working on, and that's the question of management of tires. So that's one area of work what we are doing. But we are also doing, we are working on another project which is more important, I guess, for road managers, and that's looking at the impact of different tires on the pavement. We've been running pavement tests since the end of last year, when we are testing different tire types, so in terms of the steel tires, dual tires, wide single tires, and the ultra wide tires, and trying to establish their impacts on the pavement. And that's critical in terms of setting appropriate mass axle load limits for the vehicles which are running with those different tires. Hopefully that work, we are running the last test in this month, and hopefully that work will be completed within the next couple of months, and then we can develop some sort of proposal in order to review some of those axle loads. There is continuous pressure on the industry in terms of reviewing those axle loads, and that causes concerns to the road managers, obviously, because of the potential impacts on the pavements and the networks, which is caused by heavy vehicles if axle loads are changed without the technical evidence. So I would like to separate in terms of the tire issue for managing the tires, and that's the introduction of generic tires for PBS vehicles. That's one project. The other project is looking at the impacts of tires on pavements.
Thanks, Les. Paul. Or did he answer your question?
He actually answered the question I was about to ask him. That's all it was, mate.
Okay. Any other questions?
I'm happy to hear that I answered the question, because sometimes I just carry
That
on.
was the question I got, actually, Les.
Oh, yep, behind you, Bob.
Les, it's Robert Smedley here.
Oh, you might need to turn it on.
Les, it's Robert Smedley here. You know me well.
Hi Robert, how are you doing?
Good. There's been a bit of discussion in the room around safety of larger combinations, A doubles as opposed to semis, for example. Can you elaborate for the benefit of the room why an A double? You touched on the safety impacts of it in your statistics, but why is it that an A double is safer or has less risk than a single semi-trailer?
So thanks Rob. I've got some specific numbers. I didn't, because my presentation was very short, I didn't want to put this up, but it's an interesting one because A doubles, obviously, they are introduced in a class. We are talking about level 2 vehicles, so it's roughly in the B double class. They are replacing mainly B double type of vehicles. B doubles have been known as very safe combinations, and in our safety research, when we compared the A doubles to B doubles, we found that while the A doubles have a crash rate around 12.8 per 100 million kilometers, the A doubles around 6 point something. So what are the reasons? Obviously, the previous vehicles are designed and they have to go through an assessment which is looking at their performance. Like prescriptive B doubles, they don't have that. So a part of the dimensional requirements which are there covering B doubles, they are not checked against some of the performance measures like stability, for instance. The previous vehicles are checked against 16 safety standards, so we are making it sure, and thanks to your work as well, that they are performing well. So that's issue one. The second one is, obviously, they are representing newer technology. These vehicles are normally fitted with the latest safety technologies which are available for heavy vehicles, and on the top of that, the PBS fleet is significantly younger than the normal prescriptive fleet. While the average age of the PBS fleet is around 4.8 years, the prescriptive fleet is above 10, 11, around 11. So obviously these are the newer vehicles fitted with better technology. We also have the operational conditions around those vehicles. So these vehicles are loaded properly because we have control in terms of the axle loads or payload heights. And we also have to admit that transport operators are putting their best drivers on those vehicles normally because these are huge investments. On the top of that are those calculations in terms of the potential life-saving calculations. They are poorly based on those are very conservative calculations because we didn't just look at how much these vehicles are safer, but we also looked at what is the reduction of the truck kilometers, what they travel. So that's the reduction of exposure. So if you just, and it's very simple sort of calculations. On average, we've got around 8.5 fatal accidents per 100 million kilometers. So if you look at 1 billion kilometers. So if you look at that, we save roughly let's say last year we saved 600 million kilometers, so that's roughly 60% of the savings because of less exposure, less trucks on the road, and then better performing trucks on the road. So just in a quick summary, I would say that these are the main reasons why these vehicles are performing better in terms of the safety statistics.
Thanks, Les. A question on Slido, and I don't know if you can answer it, or maybe Roy. Is there a financial incentive to having a PBS fleet as compared to a conventional fleet, such as cheaper insurance?
I'll try first. Currently, there is no direct incentives. Obviously, that potentially is changing. We've been doing lots of work with NTI, which is one of the largest insurance company in this country, covering around 48-50% of the fleet, and they are looking at. They were heavily involved in the creation of drafting that safety report, what I was talking about before, and they are actually now they have reliable crash data and data in terms of proving that that the PBS vehicles would have better safety performance. Obviously, it's a commercial decision for them in terms of the insurance and registration. Unfortunately, it's not covered by the NHVR. It's out of our hands. So while we don't have direct input into influencing that, but it's been recognized now. And I guess the key element of this is that now we've got reliable crash data to show the performance differences. Now I left Roy to address the commercial aspects of it.
Probably a question, Rob. Good answer. But obviously, you've got one less truck on the road. There's definitely going to be a commercial interest there to pay off your truck and trailers a hell of a lot quicker.
Yeah, I think a lot of operators we see are achieving somewhere in the order of 30% productivity improvement. So if you're, for every 100 trucks or freight movements that you might have, if you can move that with 30% less trucks and 30% less drivers with driver shortage, less fuel use on PBS vehicles, because an 85-tonne truck doesn't use 50% more fuel than a 68-tonne B-double. He's talking somewhere in the order of maybe 10-15% increase in fuel burn, but 50% increase in productivity. So that money goes straight to the bottom line of the operator, or passed on through to end users. In some cases, depending on what your contractual arrangements might be with Woolworths or Coles or those sorts of things. So that's where the cost savings are, is decrease in fuel burn, better tyre life, less drivers, less trucks, less equipment on the road in general, less registration costs because you've got less equipment on the road. So that's where operators are generally seeing the cost savings in moving to PBS. Les would be able to speak to this a bit, but some fleets have now almost entirely moved away to PBS. So your large fleets like Finnemore's, Pearson's are entirely PBS fleets now. Boral, Hanson, they're all entirely PBS fleets. So it's not, a lot of operators have seen the benefit of moving to it for a financial gain as well.
Okay, we can do one more final question because Roy's got Chantel. We've got a vehicle at the back for you to have a look at. One more question. No, not one more question? Okay, we can go straight to Chantel.
If there isn't any more, because I don't want to bump in. There's also some talk about pavement wear that's been coming up and damage to roads. Can you elaborate on why a larger combination doesn't, let's say it's a double the size combination, why does it not double the pavement wear?
So what when PBS standards were established, we had a number of options in terms of how you can quantify the pavement damage. What we have ended up with, and the current system is that in terms of the pavement damage, the pavement vertical loading standard is the critical in terms of establishing what is the pavement wear which is caused by the vehicles. Now, what's important to understand that the axle loads for PBS combinations are exactly the same what the axle loads for prescriptive vehicles. So if you have a steer axle, a tandem group, or a tri-axle group, the axle loads are equivalent to each other. So the PBS vehicle is not operated with higher axle loads. That means the vertical loading is the same. But what we are doing with the reduction of number of vehicles on the road, that causes significant reduction in terms of the pavement burn. If we look at the combination, it's normally the steer axle which is the most damaging in terms of the vertical load and the deflection of the pavement and also the road wear. So that's the most damaging sort of axle if we look at a heavy vehicle. So if you just in a simple way, if you reduce the number of trucks, if you reduce the number of prime movers, because you have a combination which is, let's say, hauling 2 trailers, and you get rid of 1 prime mover in that means you are getting rid of a unit which is more damaging for your pavement. So if we look at the number of the pavement wear, if you calculate it per payload, then normally the PBS vehicles are significantly more efficient in terms of pavement wear, and that leads to reduced pavement wear, which means reduced maintenance cost for the road manager as well. So we have calculations to demonstrate that.
What about the tractive effort of the drive, Les?
Now that's another element of it that, I didn't want to get into the technical nitty-gritty, but early morning, but I guess you've had a good breakfast this morning. So what also important that in terms of the PBS vehicles, we've got another standard, pavement horizontal loading, which is limiting the horizontal loads on the pavement, and the horizontal loads aren't important when the vehicle is turning or when the vehicle is climbing or going on a grade. And that's where the drive axles, in terms of the grades, starting on grades and running on grades, that's where the drive axle loads are critical in terms of making it sure that the drive axles or the drive tires are not skipping or not skidding on the pavement, because that is the most damaging effect when you have a drive group, a drive tire, which is just when the vehicle is not designed to carry the mass. Prescriptive vehicles don't have to comply with startability and gradability requirements, and we see that on some vehicles when you see that the drive axle is actually spinning and the vehicle is still not able to start or travel on a grade. So we are controlling that on the PBS vehicles, and currently we are reviewing the pavement horizontal loading standard. That's part of the PBS marketplace, and we are going to introduce a performance-based measure for controlling pavement horizontal loading. So quickly, I'm not sure if that's complete, but that's my opinion.
Thank you, Les. Okay, we're going to let you go, Les, and we're going to go and have a look at this truck out the back. Thank you.
Thanks, Mel. So this is a 30 metre A-double set, obviously flat top, operates on the level 2B network, doesn't it, Jesse? Yes. So yeah, pretty much as of yesterday, there was some good news for New South Wales and Victoria. The reference vehicles in New South Wales were accepted from Victoria were accepted across New South Wales. So any of the level 2 and level 2B networks that Richard talked about earlier, this road train combination will operate in. So obviously just on airbag suspension, road friendly, on the Firestone tyres, which is all part of the PBS DA. This will be operating in the Snowy Mountains as well, but he should, on an approved road train route, he should get about 92.5 tonne in the combination. So yeah, very easy to tow. Obviously we got it in here, no dramas at all. There's no signs down anywhere that we know of.
Did have to close the road. You were breathing in, I saw you. You only just made it, really.
Has anyone got any questions?
What are they like to drive fully loaded?
Fully loaded, just the same as any other truck, fully loaded.
As in, have you done any? No, you're right. Have you done any testing on corners like with this setup compared to like a 26 metre B double? How do you find it on, say, a set of traffic lights turning a hard left? Is it traction much the same?
This will be way easier.
Yeah,
way
I was just trying to get it out there for the technical council and that.
An A double, usually up to about 32, 33 metres, will perform as well as a 25 metre B double. So you can usually get an extra 4 or 5 metres into an A double to get through the same corner as a 25 metre B double.
Yeah, I was pity Les didn't show that. Where's Tim? Where'd Tim go? Yeah, Les has got a sweet video with drone footage, the same Tina section, truck and dog, 26 metre, then a 30 metre, and it's pretty impressive. Like yesterday coming in here, Kit car was following me in a 26, and there was a car in the right-hand lane, so he obviously hugged the car out like in front of Macca's there, and we missed the curb by a metre probably. And he come round and he's only a foot off the curb block, and in a 26 metre combination. So.
Well, I use the traffic lights here as an indication quite a lot. I haven't hit them, just for the record.
You're not going to claim it.
No, that's all right. Anyway, that's all right. I think it was you on that.
I could name one person.
But yeah, coming through there, obviously first time I'd driven a road train through there, and piece of cake, they're still standing.
Why not a try dolly?
Rob can talk to that.
I get all the tough questions. Some of the network or some of the state roads or areas around New South Wales and Queensland at the moment don't give you extra weight for the tri-dolly, so you're carrying around an extra set of axles, tyres, wheels, and not getting the benefit for it, so you're actually going backwards in payload. The other issue is if you're on a network where length is a constrainment, or so you can't go over, say, 30 metres, it's very, very hard fitting a tri-dolly. So imagine we still have this length in it. If we had to fit an extra axle underneath here, the drawbar would end up being incredibly short, and you'll find you'll probably destroy the back of the lead trailer and the drawbar every other week. So if 30 metres is a constraint that you're having to fit on where you're needing to go, say into Brisbane Port or something like that, then it's just impossible to get decent length trailers on a triaxle dolly.
Yeah, we had a problem when the highway, from the highway to Red Bend, that was open to road trains. The trucks were getting booked because they had a bogie dolly, and it's supposed to be a modern road train where they had triaxles, and the RMS were booking the trucks for the bogies. Yeah. And then they found out it was gazetted before that came in, so they had to hand it back. But there are problems between modern road trains and the old trains.
Very complicated situation, the tandem and tri-bogie dollies.
Yeah, the other thing is that states that do allow the extra 7 tonnes on the rear trailer means that you can't then split it.
Because when you go to
set extra 7 on the bogie drive means you're overloaded. So you've got to keep the combination.
Yeah, so if you were ever to split the rear trailer, you can't then put that onto a prime mover because the prime mover would be overloaded. So it has to be a point-to-point scenario, not a dropping of trailers.